P2.2, specific heat capacity. You need to know the definition for this. It's the amount of energy needed to raise the temperature of 1 kilogram of a material or a substance by 1 degree Celsius. So it's about heating up substances. And it's the amount of energy that's needed to raise the temperature of 1 kilogram of that substance by 1 degree Celsius. There is an equation which goes with this, and I'll explain it. So specific heat capacity is equal to energy divided by the mass times the temperature rise. The units are really important. We need to make sure, particularly when we're calculating these in exam questions, that the units are the same as the equation. So our energy has to be in joules, our mass needs to be in kilograms, and our temperature rise needs to be in degrees Celsius. So when we come to calculations, we need to be able to change the units when we are given units that are not the same as the ones that we need. So if we want to change joules into kilojoules, we divide by 1000. But if we want to change kilojoules to joules, which is probably what you're going to have to do for these calculations, then you multiply by 1000. Exactly the same applies to grams. Grams changing into kilograms, you divide by 1000. But if you want to change kilograms into grams, then you multiply by 1000. Okay? So that's something to remember. Make a note of that in your booklets. Okay, so this concept is about heating different materials and the amount of energy that we will need to raise its temperature. Specific heat capacity is all about heating 1 kilogram of a substance and raising its temperature by 1 degree Celsius, and then measuring the amount of energy that's needed to do that. So let's take some examples. If we take 2 glasses of squash, okay, now the little glass of squash here contains less mass than the larger one. So this one requires less energy to raise its temperature by 1 degree Celsius than this one would. Okay, that's quite obvious. I think we're all comfortable with that idea. Okay, let's look at it in a bit more detail then. So if we take 1 kilogram of water and we want to raise its temperature by 1 degree Celsius, so for example 10 to 11, yeah, that will require 4,500 joules of energy. But if we take 1 kilogram of oil and we raise its temperature by 1 degree Celsius, that requires a lot less energy, only 1,700 joules, because it's a different material. So different materials will have different specific heat capacity values. Look at iron. If we raise its temperature from 5 degrees to 6 degrees, that only requires 450 joules. So even less energy, and less still for copper, only 385 joules. Okay, so we're raising the temperature by 1 degree Celsius each time, and different materials will have different values, because some materials are easier to heat up than others. So copper requires much less energy to raise its temperature than water does. Okay, so that's one thing to remember. Let's look at 2 other factors. If we take 1 kilogram of water and we use 4,500 joules of energy, we'll raise its temperature by 1 degree. Okay, we've already said that. What happens if we increase its mass? If we double its mass? If you look at the amount of energy that's required, it's twice as much. So if we double the mass of water, we double the amount of energy required. And that makes sense, yeah? If we then look at oil, and we have the same mass of oil this time, but instead of raising its temperature by 1 degree Celsius, we're doubling that. to 2 degrees Celsius. Exactly the same applies. We double the amount of energy that's required to raise it to 2 degrees Celsius. Okay? So the factors that will influence the specific heat capacity are the type of material, the mass, and the temperature rise. So there are 3 things there that will affect the specific heat capacity.